4-7, negative exponents. You actually see the same examples written up here twice. We're going to solve it in two separate ways. The first way we're going to solve it is, or simplify it, excuse me. The first way we're going to simplify it is to use expanded form like we did several lessons ago. It's going to actually be c divided by c times c times c. And when we do that, a pair of c's cancel out, one on the top and one on the bottom. And then when we simplify it, we get 1 on the top, and c times c, we'll rewrite that as c squared. So c to the first power divided by c to the third power is 1 over c squared. Now, yesterday, when we did multiplying and dividing monomials, you noticed a way of sort of having a trick or a shortcut to divide monomials, which is what occurs right here, c to the first power divided by c to the third power. And if we use yesterday's methodology, that's going to be c to the 1 minus 3 exponent, because the bases are the same. 1 would be m, 3 would be n, and it would be m minus n. So we have c to the 1 minus 3 power. And when we simplify that, that's going to be c to the negative 2 power. Both of these answers are correct, and they're both valid. One of them is called positive exponent form, and the other one is negative exponent form. Today you're actually going to be working between the two forms. So I'm going to have you practice going from 1 over c squared, changing that into c to the negative 2 power. That's mostly what you're going to do today. But first, I want to look at exponents with 2's and get into some 2 to the negative exponents. I want you to see mathematically what actually happens in this case. So I'm going to start with 2 to the first power. That's the easy one. That's just 2. 2 to the second power is 2 times 2. I'm going to multiply them together because the math is relatively easy. I'm going to show you a pattern with that later. 2 to the third power is 2 times 2 times 2. And that's 8. My board isn't quite so aligned anymore. 2 to the fourth power is 2 times 2 times 2 times 2, which is 16. Now, remember, when we looked at this with patterns, when we did it with the 3's at the very beginning of this chapter, we noticed that going up a level, we multiplied, and going down a level, multiplying going up, and then to go down, we divided. And you can see here that to go from 16 to 8, divide by 2. 8 to 4, divide by 2. 4 to 2, divide by 2. You should notice that pattern. You should remember that pattern. Knowing that, what is 2 to the 0 power going to be using this pattern? It's going to be 1, because 2 divided by 2 is 1. And that you kind of should have remembered from the last time we did this example with the 3's, when we talked about any number raised to the 0 power is always 1. Now we're going to have negative exponents. Let's use this pattern of dividing to fill in what the numbers, the answers, are going to be. So 2 to the negative 1 power is actually going to be 1 divided by 2. It's 1/2. Because when you divide by 1 by 2, you get 1/2. So moving down another level, 2 to the negative 2 power is going to be 1/2 divided by 2, which is actually 1/4, which is the same thing as 1 over 2 times 2. 2 to the negative 3 power is 1 over 2 times 2 times 2, which is 1/8. 2 to the negative 4 power 2 times 2 times 2 times 2, 1/16. So you should notice, and I'm going to erase the divided by 2's all the way through our problem, just so we see a big pattern. Positive exponents and negative exponents, their answers are related. They are inverses of each other. Negative exponents don't give you negative numbers. Negative exponents give you fractions. And the larger the negative exponent, the smaller the fraction. So very important to remember that negative exponents give you fractions. Here is the rule. The rule says a to the negative n power is equal to 1 over a to the nth power, which is what we saw on the first board. Positive exponent and negative exponent form. So a can never be 0 in these problems as well. I need to know why. Bonus homework question. I want to know why a, the base, can never be 0. Very important. Give me details, please. So you're going to have to literally switch between these two forms today. And on the next board, I have a couple of examples. So here we have right as a positive exponent, x to the negative 5 power. Simply rewrite that as 1 over x to the positive 5 power, because that's what it is, based on our pattern from a couple of boards ago and based on the rule which we just saw. Another example, right as a negative exponent, 1 over b to the 6th power. That's actually going to be b to the negative 6th power. So they're very related, and you're just going to have to work between the two methods today. Your homework is on pages 183 and 184, problems 14 to 44, the evens.